Welcome to Educator.com. We have another instance for learning Introduction to C++. Today we're handling structures. Okay, we use structures to keep related data together. You may have noticed from a previous homework assignment that you'd have more than one array, and so you want to get the name array, and then you get the sales array and various things like that, and each one has got indexes. You have to make sure your indexes stay lined up with each other. With a structure, we can put all of that into one structure. So the syntax uses the keyword struct. We're going to cover some examples, how to access members of a structure. Once you get it into the structure, how do you get the data out? We have structures that contain other structures. We want to get to those members. How do we initialize the structures? We get an array of structures, multi-dimensional arrays of structures, pointers to structures, allocating, deallocating them. We get the memory from heap, put it in the structure. When we're done with it, put it back. And accessing members of the pointed to structure. Okay, we need to keep our data organized. The computer doesn't care where you put the data, but us humans, we need things organized. We need things to be in certain places, and it's also a little bit easier. You don't have to deal with, okay, I want name of 0, I want age of 0, I want score of 0. Just put all that into a structure, call it person or whatever. Then you have person of 0, and you get that person's age, you get that person's name. So we can keep our collections of structures versus multiple arrays of data. The multiple arrays are also troublesome when you want to keep your data in various collections, such as arrays, stacks, sets, binary trees. You have a binary tree. Binary trees, by the way, are used a lot for searching. It's like a dictionary type of thing where you want to say, well, the letter, it starts with A, so we know it's towards the beginning of the dictionary when we start looking for something. So we have, here's a few here. Here's an array of IDs. We have 100 IDs. We have 100 scores. We have 100 handicaps. Well, how do you put these three into a stack or into a set? You'd have to have 3 collections, 3 arrays, 3 stacks, 3 binary trees, what have you. But if we have a player, which consists of the ID, the score, and the handicap, it's much simpler to deal with that. So now we can put this player into this binary tree or into this array. And this is kind of leads us up to object-oriented programming, which will be covered later. But you could consider this as a object. So here's our general declaration. Here's our general syntax for declaring a structure. We have your struct keyword. I've got square brackets here in italics because you don't have to give it a structure name. You should, but you don't have to. If you don't, it's considered an anonymous struct. And then we have the type of the member and the name of the member. As many of these as you need. And then you end your curly brace. And then you can give each object, you can add those onto there. And again, these are optional. You don't have to do that. So here's an example. We have a person, struct person. He has a name, which is a string. He has a height, he has a weight, and he's got a score for whatever game the player is for. And we've got 3 players declared right here, P1, P2, and P3. Now the structures can be declared without declaring the object elements. That way you can use it as a type. You can use it as a type anyway, but it's better just leave it out and then declare them. So we can have, when you do that, you do need the semicolon, because you need the semicolon to separate your declaration section of your code from your execution part of your code. So here we have a parent structure, the name, age, and a gender. And now we can use parent like a type. Instead of being integer or double or char or what have you, we can say parent. And we have a variable mom, who is a parent. And initialize it. There's mom's name, Gracie. Mom's age, or at least what she tells us her age is. And her gender is female. And then dad, whose name is George, I don't believe his age either, and is male. So now we've got two variables that in memory somewhere, we've got mom, who has a string with whatever her name is, a float for her age, and a char for her gender. This chunk of memory has been allocated for mom, and a similar chunk of memory has been allocated for dad. Now, we're going to use some of these structures. We're going to have this example for a person who has a name, an age, and a height. So we'll have Abel. Again, don't forget that semicolon. We have Abel, who is declared to be his age. His age is 27. He's 175.5 centimeters, feet, what have you. Feet, that's pretty tall. Barbie, who is 57, oh yes, Barbie doll is 57, that's true. But she's only 12 inches is how high Barbie is. Well, this is a different Barbie. And then we have anonymous. And we did not initialize anonymous for whatever reason. But we can assign, see, these assignments were done at compile time. This assignment is at runtime. We set anonymous equal to NA00.0. Like I said, make sure you put these zeros in there so that you know what the values are. And we can use it now, when we declare it as a type, this is a variable. We can use it like any other variables, including Abel is being assigned to Abel Jr. So we have a person called Abel Jr., and all the members of Abel will be copied to all the members of Abel Jr. So it's very powerful syntax here. You can do many, many things in here. So you've got your memory chunk. We've got Abel is here. We've got his name uses up so much space. His age is here, and his height is here. This is this little section that belongs to Abel. There's all sorts of other memory out here, and there's a chunk that's Abel Jr. So we do this copy. We'll copy that to that, this to that, and that to that. Now, we've got the data now. We've got the data initialized. How do we use it and get the members to get the data back and forth between the members inside the structure? So we use the period for the most part to access a variable's member. So we have a company that has a name and a city and float their annual sales. We'll initialize C1, company 1, who's in Boston and got very little sales this year. Let's fix that. C1 dot sales is now, so we've got this number, floating point number, is stored in this member. And we can use that in an expression, just like any other expression. So let's grab the sales from this company, multiply it by 0.15, and that's the taxes that the company owes based on this tax rate, which of course should be a variable because it changes every year.